Okay, here's our first video on understanding radicals. Now I know some of you are a little, maybe you don't understand radicals. Basically, a radical is a solution to the equation x squared is equal to some number a, or x to the, so we're going to talk about square roots now, okay? So let's talk about square roots. If I needed to solve this equation, the best way to find out what x is equal to is to take the square root of both sides. When I do that, I take the square root of x squared is equal to the square root of a. Well, now the square root of x squared is x because it undoes the squaring operation, and I get the square root of a. Now, what really does this mean? Well, let's take a look. Let's go over here and talk about what's really happening here. Now, when we're talking square roots, let's talk about what the radical looks like. The radical sign kind of looks like a division sign, only it's got this little hook out here. I probably exaggerate it. And we have a number out here, n. Now, I didn't put a number out here, and there's a reason why I didn't put a number out there, because I was talking about the square root. Square root, it's understood to be a 2 out here, so we don't write it there. When I have any other number out here, I put the number out here. This number out here is called the index, I-N-D-E-X. Okay? Now what's inside of here is a number or an expression like a monomial. I could have a trinomial in there. I could have a lot of things in here. Whatever's in there is called the radicand. The radicand. Okay, and this sign, the symbol that looks like that division sign with a little hook on it, is called the radical symbol, or just the radical. And a lot of times I will call it the radical, especially when I'm talking about the square root. Now, if I was taking the square root of a number, let's talk about a number first of all. Let's talk about 56, because this is kind of a nice number to take the square root of. And I can take the square root of 66, and when I do this, the index out here is understood to be 2 because I don't have one out here. What I'm going to do is I'm going to factor 56, and you know what that looks like. Remember your tree diagram, 2 times 28, which is 2 times 14, which is 2 times 7. Now I have the prime factorization. If you remember how to do this, I have the prime factorization right there of 56, which is 2 times 2 times 2 times 7. Now, eventually you're not going to have to do this. When you understand what this is, I'm only doing this to show you what it is. And up here, if I have a 2, whatever my index is, that's how many factors that are exactly alike I'm looking for inside of here. So since it's a 2, I'm looking for 2 factors exactly alike. Well, there are 2 2's right there. Now, those 2 2's come outside of this sign. We'll take one of them out, and that's what we do. To simplify these, we bring whatever we can outside, and we leave whatever we can't bring out. Now, you can't bring it out if it doesn't have 2 of them in there, because it is the square root. And I'm left with 2 times 7 inside. Well, the 2 times 7 inside will reduce to 14. I'll put them back together again. Whatever's left in, put them back together again. Multiply them back. So you get 2 root 14, or 2 radical 14, for the answer to this. Now, let's say you had a different root, and we were going to do the cubed root of 56. Now, we call the cube root, we have special names for the square root and the cube root. When we say radical 56, we assume that we're meeting the square root of 56 over here. And when we say the cubed root, we mean 3. So the index here is 3. So if I factor my 56 in again, which since we're using the same number, I'm going to show you. Okay, there's the factoring because we already did it. And I'm looking for 3 factors now because we're doing the cubed root. And so we have 3 2's. Now to get them out of this radical sign with the 3 index, we have to have 3 exactly alike. We have 3 2's in there. And we have what's left over inside that cubed root sign is 7. So that's the answer to that one. Now let's say you want to take another root. Let's say we want to do the 4th root of something. Whatever this index is the number of factors we're looking for in here. And since we already know what the factor of 56 is, let's just multiply it by 2 and take the 4th root of 112. Okay, the 4th root of 112 is, since I just multiplied it by another factor of 2, I now have 4 2's, times 7. Okay, so I have those inside of there. That's a 7. Okay, so now I'm looking for 4 factors exactly alike inside. I have 4 2's. To bring them outside, I bring 1 out, and I leave whatever's left inside of there, again, the 4th root of 7. And that's basically all there is to doing these. Now we're going to do some more with some variables later on in another video.